Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems. Find closest node to given two nodes. Yeah, so this problem tagged as a medium and I feel so like if you know like very basic things that we are already doing from last 2 to 3 videos, then you should be in a very good state to solve it like very easily. Yes. So on this problem statement, they have given a directed graph. So now the point to take a note that it is a directed graph, not a undirected graph. So they have given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. So that is a point you can take a note, like for a particular node, the out degree or the outgoing edge for that node is only one. But I am not used that much this information. I am solved it with like basic. Consider it should work for if it is has a single outgoings, or it should be a like mesh kind of graph, so where from a single node there is a like in number of outgoing edges. Our solutions would work for that also. The graph, now on the next lines, they have mentioned the graph is represented with a given zero indexed array edges of size n, indicating that there is a directed edge from node I to edges of I. If there is no outgoing edge from I, then edges of I is holding -1. So very straightforward, I feel so. Very straightforward, I feel so. So if you can see, so they have mentioned these edges they have given as 2, 2, 3, 1. So 2 means from what is the index number? Index number is 0. So from 0 to 2, there is an edge. Yes, from 0 to 2 there is an edge. So index number 1 edge value is 2. So that means from 1 to 2 there is an edge. 1 to 2 there is an edge. Index value is 2 and edges value is 3. So from 2 to 3 there is an edge. Index value is 3 and edges value is -1. So from 3 we don't have any outgoing. Yes, like this the graph has represented it. I think very straightforward. Nothing like, so either they can give you an UV, like from U to V there is an edge, or this representations is also kind of similar only. So we just have to take care, like if the edges of I is -1, so we don't have to consider it at all. So that means from this particular node there is no outgoings at all. So why they have basically, so if you understood like every lines in your brain, like everything's why they have given the graphs in this order, but on generals they are giving in UV pair, but in this particulars why they have given is like this. If you like think of like everything's in a deeper way, you will definitely get a like different way of thinking. So why this works, why this representation has works, because the first lines, every node has a single outgoing, so if from node 2, so that means what is the I value then? 0, 1, 2. So from node 2, if so this representations only work if there is a single outgoing we have to represent. So that means from 0, 1, 2 there is the outgoing of 2 to 3. But let's suppose it is a mesh graph. From 2 to 0 also there is an edge. From 2 to 0 there is an edge. Then they have to provide in a UV pair. So that's the reason this particular input formations is work for this particular example, because they have clearly mentioned for every node there is a single outgoing edge. At most there is a single outgoing edge. Now return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance of node 1 to the node and from the node 2 to that node is minimized. I think a little bit complex, but I will give you a one note explanations for sure. If there are multiple answers, return the node with the smallest index. And if no possible answer exists, then return -1. Note that edges may contain cycles. So that is the point they have asked to note. So now these lines I think a little bit confusing. So let me just put it on your plate in a simple format. So what they are looking for, so they are basically looking for, if that is a node, so they are looking for, so let's suppose it is my node 1. So there are two values of node, they are also given to us. So here you can see they are basically looking for return the index of the node that can be reached from both node 1 and node 2. So they have given the two values of node 1 and node 2, and we have to find a node which is reachable from both node 1 and node 2, and the maximum between the distance of node 1 to that node and the node 2 to that node is minimized. So now let's suppose our node 1 value is 0, and let's suppose our node, this is another node, and that is my node 2, and let's suppose there is this graph is working x, then y, then this y. So what is the point? What is the point where which node is reachable from both the node? Which node is reachable from both the node? And let's suppose there is p, and let's suppose from here also a node is q, and there is okay only single outgoing. So we have done for it. So everyone's has a single outgoing, right? Everyone's has a, sorry, this I actually make it wrong. So it's kind of this only. So let's suppose there is, let's consider this on this only. Make it simple. So let me redraw 0, this 1, then 2, and from 3 this node is reachable, and from here let's suppose this is my node 4, right? So and this is my node 1, and this is my node 2. Now tell me guys, which node, which are the set of nodes? So more specifically you have to say which are the set of nodes, who are, those are reachable from both the nodes, this one, because the path is this reached, so this is the first node which is reachable from both the nodes, yes, agreeing guys? What is, do we have any more nodes? Yes, you can reach to this node also, this and this, yes. So these two nodes are reachable from both the nodes, now we have to return some of these, but whom? So now the condition is the maximum distance, what is the distance from node 0? What is the distance of this node? 1, 2, right? What is the distance from node 3 to 2? That is 1, like on single only we are able to reach. So this node is at a distance of 2 from node 1 and at a distance of 1 from node 2. Now we have to take the maximum of those. That is mentioned in the problem statement. So we have to take in the maximum of those. If a particular node is, so we only have to consider that node which are reachable from both node 1 and node 2, which is reachable from both node 1 and node 2. Who are those? 2 and 4. And now we have to check what is the distance of the intersections or the common nodes which are reachable from both the nodes. What is the distance? So node 2 is a distance of 2 from node 1 and at a distance of 1 from node 2. Now we have to take maximum of those. What is the maximum? The distance is 2. 2 and 1 maximum is 2. And now they are looking for the minimum of those. So let's suppose this node is at a distance of 3 from node 1 and at a distance of 2 from node 2. Yes. So the maximum of is 3. And like this way, let's suppose there are, so one node at a distance of, intersection node is at a distance of 2, another node is at a distance of 3. Like this way we have multiple intersections node. So we have to consider like this, we have to consider to all of them which are at minimum distance. We have to take minimum of those. So basically we have to consider the intersection node, and when we are at the intersection node we have to check what is the distance from node 1, and we will going to take, okay, from node 1 I need 3 minutes, from node 2 I need 2 minutes. So I definitely need 3 minutes to reach this intersection node, so the value we are going to stamp on that particular node is 3, because the maximum of node 1 and node 2. Let's suppose consider you are traveling to a particular point from you and your friends. So from your friends and you have a party plan to an intersection point, right? And from your friend house it will going to take 3 minutes, and from your house it is to reach the party point to 2 minutes. So when you are guys going to start the party, when everyone is reached, when your friends should be reached, no, then only you can start the party. So you have to take all the invite is maximum reaching time, right? So that's kind of problem only it is. So try to relate every problems to a real life problem. So let's suppose you have 5 friends decided to basically meet to a particular party point. Now when you can start the party, like think on very general, when everyone has reached, so you have to take the maximum time need to reach all of the friends, to reach all of the friends. So that's the reason they have basically asked to what is the maximum time to reach the intersection node from node 1 and from node 2, from node 1 and from node 2. And now we are basically stumping the party point. We are basically stumping. So that is one party point which is at max of 2 minutes distance, which is at max of 2 minutes distance from all of our friend circle home, from all of our friend circle home. And there is another party point which is at 3 minutes distance from all of our friend circle home, from all of our friend circle. So where you are, where you all are basically then plan your party. Yes, obviously which are at minimum distance. Yes, obviously which are at minimum. So that's the reason they are basically looking for the minimum of the intersection point. So we have to consider whichever of them has minimum intersection time. So you will take the maximum reachable time, maximum time to reach from every of your friends to that party point, and we have to decide the party points in optimally so that the overall to the maximum people, if we consider to all of our friends to be able to meet, and everyone should need a very small time, the minimum time we need to start the party. So that's why we have to choose the intersection party point, right? And now there is one more case they have considered. I think it should be clear to you, but if not, I will definitely suggest to rewind this video on this particular expressions, because no further expressions can be better than this. I have put it in a real example to you guys so that you can relate to your own. So now, if let's suppose there is another node, now let's suppose there is another node which is, let's suppose, one distance from one friend's house and two distance from second friend house. So let this party points is two distance from first and one distance, like 1 minute distance from the second. But there is one more party point which is one distance from first but two minutes distance from the second. So in that case, here also you are going to get another party points of two distance. So now if you have a kind of multiple answers possible. So there are multiple party points you guys have found where, like, some friends need a little bit more time and some other friends need some lesser time, and like this way. But the maximum times of all the friends is constant, which is 2 on the case. So then on that case, they have asked to choose the node or the party point having minimum index. So let's suppose this node index is 0 and this node index is 1, then you have to choose this. So that is this question specific they have asked. So if both, like, in, let's suppose, x number of nodes at same distance, then you are going to choose which are at minimum index value. And we know on our graph every nodes are indexed from 0 to n-1. Yes, I think it's bound to be clear to you, but if not, then I will definitely suggest to rewind the video. You will get it. So now we can quickly go to some of the example discuss. But yeah, top of that, if let's suppose you are not able to find any intersections point where you guys can meet, then on that case you can return a -1. I think very straightforward. So let's suppose it's kind of a, what can I say, like, the node they are looking for, that node is altogether not reachable from like, so that node should be reachable, like, right, from all of our friend circle, otherwise so we can't do a party. Yes, so let's suppose you have basically set a party points in between, like what can I say, like a particular points, let's suppose in Maldives, right? So and one friend is already, let's suppose, has not enough funds to reach the Maldives, then on that case he will not be able to attend the party point. So you can't, you are not, like, allowed to do so. So if that particular node, let's suppose the Maldives that we are considering, is altogether not reachable from all the friends, then you don't have to consider it to answer calculation. Then you can return a -1. Okay, we are not doing party at all, like this. Yes. So on this example test case, that is the graphs you can build with these edges, and from 0 and 1. So these are the two friends who are coming. So from 0 and 1, it's very clear that is the intersection point where we can do a party. So that is, from here also it is take 1 minute, from here also it is take 1 minute. That's exactly they have written. The distance from 0 to node 2 is 1, and the distance from node 1 to 2 is, from 1 to 2 is also 1. The maximum of those is 1, right? And it can be proven that we cannot get a node with a smaller maximum distance than 1. So we return node 2. So that is the party point. Yes. Very straightforward. Now this is an example test case. So that is the graph, and you have a target to do to your one friend is coming from this particular node, and your another friend is coming from this particular node. So which of the possible options you can do a party? On 0th node, from 2 to 0, have we ever opportunity to reach it? No. From 1, no, 2 can't go. From 2, yes, from 0 to 1 to 2 we can do a party here, and from 2 to 2 the distance is 0. Yes, so the maximum of this 2 only. So here you can see the distance from node 0 to node 2 is 2, and the distance from node 2 to itself is 0. The maximum of those intersection is 2. So it can be proven that we cannot get a node with a smaller maximum distance than 2. So we can return 2 from this particular distance. I think the problem is very straightforward now, and you guys are going to get a very good gist of this particular problem. Now let's try to build the intuitions. I will definitely suggest to take a pause and think on your own. There is no extra magics that we have incorporated to this video. Everything that we are already solved, BFS, DFS, exactly that things is going to be worked from for sure here. So on the first example discuss, let's basically do the problems in what is the things, what is the steps we have. So draw some dummy graphs until you get problem understanding. Yes, until you can get the problem understanding. So the problem that has done. So we have draw some dummy graph and understood the problems in very detail, and also test cases is set to our brain. The second thing is, can we break to some independent subproblems. Do we have this opportunity? Yes, we have this opportunity. How? Because we have two friends only. So for our example case, we have only two friends. Right? We have only two friends. So we can consider what is the time to reach. So from node 1, we can check what is the time, what is the minimum time, or what is the, like, that is not a weighted graph, that is of unweighted graph. So the minimum time is nothing but a label order traversal. Agree guys? What is the minimum time is nothing but a label. So if I am standing at node 1, so all the nodes who are basically neighbor of my, so that are at 1 distance apart. The nodes that are of neighbor of my neighbor are of 2 distance apart. So I basically need the time. Let's forget about this mean. I need the time, or more specifically have to say the levels of my all the nodes starting BFS from node 1. Yes. So like this way, we have a DP kind of tables, or a distance tables you can consider, where basically it will hold. It is very standard BFS. We will do a very standard BFS. So what we will do? So let's suppose we have 3 nodes, 0, 1, 2. So these are my nodes, and this, so these are my index actually, and this basically x, y, and z. So this value is basically storing what is the time taken, or how far, or the distance from node 1. Node 1 is nothing but, what is the node 1 they will give us, from node 1 to node 0. This value, this x signifies this. Tell me guys, this y will signifies what? The same things from node 1 to node 1. Yes, from node 1 to that index 1 node, and what is this? From node 1 to index 2s node. So this actually holding what is how far, what is the distance from my this target node to that particular node to be reached. So now, so that we will do on my, by calling a BFS functions with node 1. Now can we do similar things for node 2? Yes, I definitely need to do. So I need, shit yaar, now it will take 1 minute. So I definitely need a kind of things from the same things from node 2. On the DP tables, I need what is the distance from node 2. It will going to take to all the nodes, and I need. So let's suppose I will first call my BFS. To calculate it, and it will holding the value. And when I am considering that node 2, can I use the same DP tables? So on the DP tables, what we are looking for? We are basically looking for the maximum of those, because that we have just saw, right? The intersections point that we are planning to do, we are basically looking for maximum of those. So we are basically looking for max of what is the DP of I is already holding to the current text. So the current text is by calling the BFS from node 2. Like this, it is holding. Like this, it is holding. Yes. Agreeing guys, right? So if I can draw a dummy graph, this, and let's suppose this, and let's suppose this is my node 1 and this is my node 2. So this is my node 1 and this is my node 2. Yes. So which is the intersection node? Which is the intersection node where both node can reach, So I will first do a level order traversal. So this all levels is at distance of so this is not a valid altogether because only a single outgoings they have allowed. So only this node is at tell me guys, is at level of, so this is at a distance of 1. Now this node is at a distance of 2. Yes. So this node is not altogether reachable because there is no path at all. This node is at a level of 3. Yes. Agreeing. And further we are not able to proceed further. So this node is holding a value of -1. So now again, so what is the value? So this is -1 and this is also -1. Yes. Right. So that is the entry in my DP tables. Now I will trigger my BFS from this node 2. I will trigger my BFS, the same things I will try to do from this node. And now I am able to reach this particular node at level 1 distance. So DP is already holding level 3 and now we are able to reach it at level 1 by calling same BFS functions with some different values, with node 2 value. Yes, agreeing guys, totally agreeing. So now how many is so on DP tables, which of the nodes is holding. So let's suppose there is a node kind of this, which is, so this node is not reachable from this node, but it is reachable from this node. So for this case, if when I am triggering a BFS from here, so this node is going to take a value of level 1. But am I interested to this kind of nodes which are reachable from one particular node? So that means only my single friend is able to reach. No, I am not interested. So when I am triggering my BFS, I will only consider to calculate my answer where my DP, I will initialize my DP to be -1 into n. So that means my all the nodes are not exposed at all. And when I am going to do a BFS for with node 1, then my DP of node. So this is holding a value, this is holding a value, but this node is holding -1. This node is holding -1. This node is also holding -1. So now from here, when we are triggering a BFS, this node is also a level 1 node, right? But do I consider this node because DP of this particular node is holding -1. So that means because I will trigger my BFS in the order, no? So first I will trigger for node 1 and then I will trigger for node 2. So in my DP tables, the values which are not -1, so that means this node are reachable from node 1. Those values which are not -1, that node are reachable from node 1. Agreeing guys. So this node is altogether not reachable from my node 1. Then is it a valid party point? No. Then on that particular points, when I'm going to update, when I'm going to basically making a formula. So here I have to make a formula of max of those, right? I have to take a formula of max of those because that is a valid intersections point where my all of the friends is able to reach, but where my DP is already holding -1. So that means my node 1 is not able to reach, right? So we don't have to consider. And now for this node 2, I will check which of all the party points, which are all the party points which are reachables, which are all the party points where I can reach, which are all the party points where I can reach. So let's suppose there is another node here and I am able to, so that is of, let's suppose, level 4 and level 2. So basically so there are multiple party points we will find. So where my DP is not equals to -1, so this node is actually, this party point is we are able to reach from first node, and we are also able to reach from second node also, from second, and we have to take maximum of those. We have to take here also maximum, and out of them we know we have to take a minimum. Yes. So like this way, when we find a particular node, when we are basically doing first BFS is very simple. I will just put whoever the nodes with the level order traversal we are exposing, we are putting their targeted levels to that particular node value. Yes, we will do that simple things. And when we are doing for BFS of node 2, then on that times we will basically calculate the answer for which DP is altogether not holding -1. So that means this node has exposed by node 1. So my one friend is already able to reach that particular node. So can I reach? Yes, I am also able to reach. So then what is the time we need? Maximum of my DP of I. What is my node 1 value is what is the time my node 1 is going to take, and what is my current time is taking, and I am basically looking for maximum of those. If that particular value, let's suppose if that particular value is minimum, that the current, we will definitely follow a minimum intersection variables. So minimum intersection variables. So if that if this max value is altogether smaller than my minimum intersection, so that is the this max value is altogether smaller than my minimum intersection point, so this particular party point is definitely a valid point, so I'll definitely store my answer to that particular node index, There is one more case, if that, let's suppose this particular party point, the max of it is equivalent to my minimum intersection time, if that is the case, then also we have to think about something. Can you guys tell me? Yes, on that case, we on this question perspective, they are basically asking for what is the minimum of answer if this particular node is at some lesser index, then consider that to your answer. Then we will take a answer of minimum of answer and node. But if this is the case, then we have to take, because that is the minimum time altogether taken. But here it is equivalent to the minimum time, but it is not smaller than my minimum time. Then on that case, I am only considering you if your index is smaller than whatever the answer index I have already stored. And on this case, we are only updating the answer. But on this particular case, we are updating our answer, and we will update our minimum intersection time to the max value. What is the max value we have? Yes. I think the problem on high levels is bound to clear to you. I have tried my best to explain. And now let's do a quick code iterations. So the code is very simple, guys. Like I wrote it like you might be like in the favor of 52 lines code, it is going to be crazy. But no man, no, it's just like the template that we are following from our last 2 to 3 videos. So that is the beauty of template. If a template is set to your brain, then you can use that template to the n number of questions, like all the questions that you are solving, and you are basically solving these questions like this way, and like 50 to 100 lines of code, you can write it like this, because the template is your brains, So 2 plus 3. Ever you are going to forget? No. Like this way, you have to like set the intuitions building to your, like this BFS, DFS template to your vein kind of thing. So never ever you are going to think about where I have to mark the visited, where I have to push to my queue, where I have to pop my queue. So these things you should not have to time to think on a real product-based company interview. You just have to type it when you find your logic. So you have to spend your time only logic building things that we just saw. So what is the like this particular question specific what games we have to play? So we have only spent time on that particular points. But writing code, 52 lines code, 2 minutes, 3 minutes, maximum 5 minutes, 10 minutes should be sufficient, more than sufficient, I have to say. So I am considering you are targeting for top product based companies, no? So this much practice you have to do actually. Now quickly go to the code iteration. So graph in, we have defined default ticked off lists, and n is len of edges, and here I have initializing my graph. So here basically you can take a look. So how I am basically initializing the graph, I am iterating for I in range n. If that edges of I not equals to -1, if it is -1, then we get rid of this. We get rid of this. If it is not a -1, then graph of I, we are appending on graph of I, we are appending edges of I. We are appending on graph of I, we are appending edges of I. Agree? Simple things. Now we have initialized our dp to be -1 into n, and we are making a helper call. So in helper calls, first helper 1 we will invoke with node 1 that we have already discussed. So we have call our helper with node 1. Now queue current level visited that we are following to all of our video. Queue is dq, current level is 0, because that is the node that we are considering where we are starting our BFS, and this is our visited, that is our default ticked of int, and I'm pushing my current node to my these things, what it is, queue, and I am marking it as visited. Then I am doing the standard, very standard naive BFS I have done here. So by len of queue, nn equals to len of queue, and on this particular level, what all the nodes, I will just want to pull them up. So this nn is giving me from a particular level, who all are the nodes. So here you can see I am iterating for underscore in range nn, and I am getting all the nodes of that particular levels, and I am basically updating their dp value to the current levels, because that is the reachable path, or that is the distance to reach that particular node starting from node 1. So I am storing it. Now I am checking for neighboring graph of node. If it is not visited, then go for push it to your queue and do it as a visited. And after this for loop executions, we have the queue with feed of next level of nodes to next level of nodes. So how you can go to next level? Current level plus equals to 1. So that means you are in next level. And now it is an helper 2 calls. Same calls I have made helper 2 with expected is node 2. Same things I have done. Same things that we have just saw to our one note explanations. I have make an helper 2 calls with node 2, and I am here storing my answer to be n plus 1. So what is the maximum distance two nodes can have? What is the maximum distance two node, or what is the answer value it can have? So it should be like anyone from my nodes altogether, and I know my nodes are in between of range 0 to n, is in between in range of 0 to n. So I have initialized a like invalid value. So that is the maximum of this, because I need to minimize my answer. So I have initialized my index node, who is actually the intersection party points we have to do to n plus 1, because that is not altogether valid, because that is of not, there is no node exist in my graph altogether which is holding an index value of n plus 1, because we know everyone is 0 to n minus 1. And my minimum intersection point, I am holding it also a invalid value to n plus 1, because I have to minimize those. Now same q current level viz dq 0 default dict of int push q dot append node visited it out. Then I am doing a standard BFS again, while len of q nn equals to len of q for underscore in range nn nd equals to q dot pop left. So I got a node, and now this extra things, this particular problem specific games we have to play. Otherwise it is standard BFS. So here you can see these particular functions and this particular functions is exactly identical, except the highlighted area that I have seen you guys. So apart from that, it is identical. So that's the reasons. Every question has its own beauty. That things you just have to incorporate to your template, then you are going to get an easy for sure. So now understand it. So we have already discussed, we will only going to consider that particular node to calculate my answer, if its value is not equals to -1. So that means what it means, not equals to -1, what it means actually. So this means this particular ND is already reached by node 1. Okay, so we only have to consider those nodes who are actually reachable from my node 1, right? Otherwise, what is the value to consider it? So because my node 1 is altogether not able to reach, one friend is altogether not able to reach my party points, do I have to consider it at all? No. So if my friend, that is my node 1, is able to reach it, then I have to consider it to answer calculation. Then my DP of node is nothing but max of DP of node. So that means my node 1's value, what my friend 1 is going to take it, and what I am going to take, and what is the time I am going to take. I need the maximum of those, because after this only we can start the party when we both reached. So I am taking max of DP of node, my friend's reachable time and my reachable time, and I am storing it to my DP of node. Now these two cases, if that particular node is come out to be the minimum of my minimum intersection point, so that means this variables is holding what is the node, which is basically, sorry, this variables is holding what is the minimum distance, or what is the minimum intersections time we actually need to reach my base to base party point. If this node is coming as to be more smaller than my minimum intersection point, then why not we can do a party on this node altogether. This node should be my party point altogether. Yes. So I have to update. I have to blindly update my answer to be that current node, because this is my party point. No further node is reachable from this particular node. Yes. And my minimum intersection is going to update to be my DP of node. Very straightforward, please. Very straightforward, very simple. And if it is equivalent to my minimum intersections point, then I have to check. Then my minimum intersection point should be same on. But it can be my answer. It can be one of my answer. It can be my answer. Is it possible to consider it as my answer? Then I have to check. If my answer, so I have to update my answer to whatever the answer we are already considering. Because if two nodes are giving me the same minimum time, then I have to consider the which of them is at minimum index, So I am taking minimum of answer and ND on that particular case if it is equivalent to my minimum intersection point. That's it. And these things is exactly same for neighbor in graph of node. If neighbor is not visited, do it visit and push it to your queue. And when you have pushed it, when you have done to this particular levels, you are going to reach to our next levels. So on next level, you can play your game. Your current levels is equivalent to plus equals to 1. So that means we reach to next level. The same things we did. And finally, we can return our answer from here. And so on helper 2, on node to call, it is returning me the final answer. Now there is a -1 case, you guys is remembered. So that means we didn't have encountered not able to find any party points where my both friends can reach. Yes, if then I am super sad, and then on that case my answer is holding n plus 1 only, because I have declared my answer to be a like non-reachable node. Like this node is altogether not exist to my given graph. So if my answer is holding that value, so that means we have not found any of this particular lines has never executed. So we can return a -1. And if that is not so, then we can return a 1 answer. Yes guys, so the problem is as simple as that. Only things is this particular game and the one note explanations that we did. So if you are able to do so that, then this problems is kind of a cakewalk for you. So we have, see guys, we have used our own template that we are following from last 2 to 3 videos, and see, we have wrote 52 lines of code like this only, and it is going to get you an S. But you have to think a little bit for every question to get question specific things. Apart from that, it is just like how you can play with your template with a smarter way. Yes. So now we can quickly discuss to the time complexity. So the time complexity of this particular algo is definitely BFS time complexity. BFS how much? Like this is a standard BFS we are doing, and here also we are doing a standard BFS only. So the time complexity is kind of big of 2v plus e, big of 2 into v plus e, big of 2 into v plus e, not more than this, not more than this. I'm not considering like this graph creations time at all, because that is not, you have to explicitly tell your interview. And what is the space we are considering here? So the space that we are considering here, so the graph is altogether big of v plus e kind of things, because adjacency list representations we are taking. But I think it is not, because we have a single outgoing, so it is like kind of big of v only, and we are defining our queue to be 2q we are defining, and we have also initialized a dp. So you can write it in kind of big of n only. Yes, dp q, this will only work to big of n only, because there we are only pushing the node values. And here also in our graph you can see, as we have only single outgoing, as it is as only a single outgoing, so it is not going to take a adjacency list. It is a kind of map only, key value. So that's the reasons, no, they have able to give you the entire adjacency list or the edges to be a single list only. They have don't need a 2D list altogether. They have able to give you in a single D list. So for our case also, the storage is going to take key value. So that is a big of n for sure. Yes guys, so that is the most optimal time and space complexity that I am able to think of for this particular problems. But I am agreeing, like there is a way, like we can make a single BFS calls to solve it. There is a way, definitely. I have an hunch to basically we should be able to solve it in kind of big of single, like a single v plus e, not like twice kind of iterations, twice kind of visitations for all the nodes. But I think so, like this is more cleaner versions of it to write it. So you are mostly going to take a time to be on the reduced path, but maybe readability we have to compromise. But if you think like you are able to reach kind of quadratic complexity to be a linear, then only go for that. Then I am totally fine to, if you are going to opt for like optimized versions. But if you just able to reach to make the time complexity to be like, if it is n, then you are able to make it like n minus 1, n minus 2, then please stay on the readability things. But I would suggest please discuss these things in a very loud to your interviewer, which particular things they are specifically looking for. But yeah, for my case, I will more taking focus on readable code only. So this code you can see is more readable, because this helper one is completely working to my node 1 operations, and my helper 2 is completely working to my node 2 operations. And here I am basically playing my game. In between my these calculations. So I personally feel this particular versions of code writing is more readable. But yeah, like explicitly talk to your interviewer which one he or she is going to be more comfortable, and write it accordingly. But yeah, I understood, like merging the both logic to a single functions is kind of a multi-source BFS, and it is kind of a like complex, or not a kind of it is a error prone. I am totally agreeing. It might be an error prone also. You will get some wrong answer also, but this one is more cleaner and more simpler to implement. Yes guys, so I have tried my best to explain to you guys, and if you guys are able to understand till this point the entire explanations, the entire one note explanations that we did, from time complex, from intuitions building to reach the most optimized time and space complexity for this particular problem, then please guys, please do subscribe to our channel, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their TSS skills. And please turn on the notifications, so that when we are going to live to our next video, you will going to get the notification as soon as possible guys. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys. Bye.